About chapter 7 transcendental functions. Let's see what they are. We are going to be talking about the inverse functions and their derivatives. What's an inverse function? A function is going to be before we say that a function is inverse, we have to understand first or recall what a one-to-one function is. A function f of x is one-to-one on its domain. If the images are not the same, then the x's that goes to the images are not the same, so they differ. If f of x1 is not equal to f of x2, then whenever x1 is not equal to x2. In other words, you can consider this like this. Two different elements cannot go to the same value. Okay, this is what it means. So two different elements has to go to two different values. That's what it would mean. Okay, let's see some examples. Y is equal to x cubed. This is our simple example, popular example we use. Y is equal to x cubed. This is one-to-one. Because you can use this test, this horizontal test. Actually, horizontal test is going to tell you, if you have an horizontal test, if you go through the graph, it's going to hit the function only at one point. Y is equal to square root of x is also one-to-one. On the other hand, y is equal to x squared is not one-to-one, because if you use the horizontal test, a horizontal line test, you're going to see that negative 1 and 1 goes to the same value 1, so it's not one-to-one. For example, y is equal to sine x is not one-to-one, because look at pi over 6 and 5 pi over 6, they go to the same value, 0.5. Yeah, this I just showed you the horizontal line test. Let's give a definition of it. A function is one-to-one. A function f of x is one-to-one if and only if its graph intersects each horizontal line at most once. That's what it means. If you remember, we have the vertical line test for the functions, and this is a horizontal line test for one-to-one functions. Okay, then what's an inverse function? First of all, we have a function y is equal to f of x, and we require that function to be one-to-one at first on its domain with range r, domain D and range r. The inverse function f inverse, the notation is f to the negative 1 is defined as f inverse b is equal to a if f of a is equal to b. Okay, so that's the definition. As long as since it's one-to-one, a would go to only one, b, right? So f inverse would be defined, and the inverse image of b is going to be a. The domain of f inverse is r, and the range of f inverse is d. So f inverse is going to actually interchange the places of domain and range. That's what it means. Okay, let's see some examples. I hope you can see them here. Okay, let's see if I can make it a little bit bigger. Let's see. Okay, so let's consider this y is equal to f of x here in part A. Here is the domain of f, and here is the range of f, okay? And we want to find the inverse of this graph. We are going to draw it in C, and let's see. Yes. In the graph B, it shows okay, it's going to show the domain of f inverse and range of f inverse. Okay, all right. So, but the graph we are going to be drawing is the step is as follows. If this is our original f, which we have here, what you're going to do, you're going to draw y is equal to x. This is the origin, by the way. Alright, I'm just, okay, there's a typo here. Okay, here, this is the 0, by the way, okay? Just ignore this y in here, okay? There's a little bit of typo here. This is the origin 0, and you're going to draw a y-axis here. And do you see that the domain and range, do you see that the domain and range of the function is reversed now? Look, the reds, let me see, this was the domain of f, and the domain of f inverse is in here. Now it's gonna come, it's switched to here, because, yeah, the green part comes in here, and the red would go up here, okay? So this is, look, x and y shifted. Look, this is x, this is y. You can consider they are doing it upside down, okay? So, okay, the simple way to say it, what you're going to do is you're going to draw a y equal to x axis here, and you're going to get a mirror image. The mirror image is going to be the f inverse, okay? It's the reflection. The range and domain is changing as well. Look, the domain is now this, and the range is up here. Do you see that? Okay. So let's see an example. Which one is our f? Our f is 1 over the blue one, 1 over 2x plus 1. This is the blue one, and now we want to find the mirror image with respect to the y is equal to x to get the inverse. Let's draw our red dots here. This is y is equal to x, and just take the mirror image of that. The mirror image of this is this yellow part. The mirror image of the blue is this one. So this is the graph. And if you want to find what the formula is, you have to interchange x and y and solve for y. That's how you would get this y is equal to 2x minus 2. So you're going to interchange, this is our original function, interchange y with x. So you're going to say x is equal to 1 over 2y plus 1. And then just solve for y, then you will get this equation. That's the way to do it. We have another example. We have said that y is equal to x squared. Whenever we said that y is equal to x squared is not 1 to 1. However, if you change the domain to x greater or equal to 0, look, y is equal to x squared, x greater or equal to 0, then it's 1 to 1. It passes the horizontal line test. Therefore, it is an inverse. Then what we do, the same procedure, we are going to draw this y is equal to x, and we look at the mirror image. The mirror image is going to give us this yellow graph. Actually, yellow graph is the graph of y is equal to square root of x. How would I know? The same procedure, interchange y with x and solve for y. So instead of y, write x. Instead of x, write for y. Then y squared is equal to x. Isolate y. You get y is equal to square root of x. We have to take the positive side. There's negative side too. But we take the positive side, we get the inverse of it. Okay, now the goal of this section was, how would you find a derivative of an inverse? The derivative of an inverse is actually very simple. It is the derivative of an inverse at the point B is equal to 1 over f prime a. Alright? Or you can also say it, the derivative of the inverse at B. Okay, so these are the graphs of inverse functions which have the reciprocal slopes at corresponding points. Okay, do you see? So this is the derivative of f at a. So the slope is like this. And what's the reciprocal of this? If they say this is 5, they say the reciprocal is, the slope is 5. And the slope of the derivative at b, which is the inverse image of a, is going to be 1 over 5. So it's going to be smaller. The slope is going to be a lot smaller here. Okay, so let's summarize the derivative rule for inverses. If f is an interval I as domain and f prime if f is differentiable, which means f prime exists and never 0 on the interval, then we have to make sure that it's never 0, right? Because we are using it in Formula 1. F prime, f inverse, the derivative of f inverse at b is 1 over the derivative of f at that point. So we don't want it to be 0. So we have to assume that it's never 0 on the interval I. Then f inverse is differentiable at every point in its domain, which is the domain is the range of f. The value of the f inverse, the value of the derivative of f inverse at a point b in the domain of f inverse is the reciprocal of the value of the f prime at the point a, which is the inverse of b. Okay? Or in short, you can see it like this. The derivative of the inverse at x is equal to b is equal to 1 over the derivative of f at inverse of f at b. Okay? That's good. Alright, okay, we have another picture. So we have seen y is equal to x squared, x greater than 0. We have drawn the graph of the f inverse. Let's find the slope in here. The slope in here is, take the derivative 2x, evaluate it 2, it is 4. The slope is 4. And then how about the slope of the inverse? Slope of the inverse is, what would you do is 1 over the derivative of f at the inverse point. Okay, derivative of f is 2x at the inverse of it. Okay, so it is the reciprocal of the slope 4, so it's 1 over 4. Okay, that's it. Okay, what is the, so these are inverse functions to each other. What is, okay, if let's find the slope at this point at 2, the slope is gonna be, take the derivative 3x squared, put 2 here, you get 12, and the slope at 6 for the inverse function is 1 over 12. It's just easy.